Hi everyone. What I want to do now is go over the classwork from Wednesday, April 29th. Getting back into trigonometry and the application of word problems, I feel like it's a little bit more applied. What I'm going to do is first I want you guys to do is watch this video here and take detailed notes. Then you'll send me those notes, and after that, you can look at the video I'm creating right now and do some of these. Do each of these problems, 4, 5, 6, and 7. Um, let's look at the directions here. So I'm going to do one of these. It says complete the following word problems using right triangle trig. Remember to label the sides of your triangle and to correctly use either sine, cosine, or tangent to solve. So that's a good reminder for doing these. Even if you don't get full credit, you'll get partial credit if you correctly use sine, cosine, or tangent, or if you correctly label it opposite, adjacent, hypotenuse, the correct sides. So what I'm going to do for this is I'm going to do number 4, and then you guys will do 5, 6, and 7 on your own. So let me just grab a screenshot of this. Okay. So it says from point P on the ground, the angle of elevation of an airplane is 23 degrees. The altitude of the plane is 1,200 meters. What is the distance from point P to the airplane, to the nearest tenth of a meter? I think what's actually a little bit tricky about this problem is it's asking what is the distance from point P to the airplane. So if you look at this picture, how far is the airplane from P? I'm really glad they gave this picture here. I think that distance is actually this distance, x. I'm going to call it x. From here over to here. You see that that's not the distance, I guess, on the ground from where, like, I guess if the plane were directly overhead, but it's for the actual distance. If you, like, attached a string or a rope to this airplane, how far would that rope be from where it is on the ground? That's what we're trying to figure out. So that's x. First step, after we have our triangle, is to label our sides. So let's see. Let's label each of our sides. This is our reference angle. And first I always find the hypotenuse. The hypotenuse is always across from the right angle. So that's our x. So I'm going to call this our hypotenuse. And then our opposite is always across from the reference angle. So this is our opposite. And then by default, this must be our adjacent. So we got most of what we need for this. Now, let's see. What we want to do is we want to determine the correct equation here. So for this equation, we got to use the SOHCAHTOA acronym. So SOHCAHTOA. Let's make this a little bit longer. So SOHCAHTOA. So what we want to do is we want to use the one that has the opposite in it, because that's the one what we know, and the hypotenuse in it, because that's what we're trying to find. We're trying to find this distance over here. So what has opposite and hypotenuse? And that would be our SO. Sine of theta is opposite over hypotenuse. So let's use that equation. So the sine of theta is equal to the opposite over the hypotenuse. So let's actually plug in our values here. So that means that it'll be the sine of 23 is our theta. So the sine of 23 is equal to the opposite over the adjacent. So the opposite is 1200 all over, sorry, I said the adjacent, opposite over hypotenuse. So our hypotenuse is our x. So what we want to do is we want to get x by itself. So we want to do that. The algebra I like to do is I like to multiply both sides by x. multiply by x, multiply by x. So then the next line, you'll have x times the sine of theta times the sine of 23 is our theta, is equal to, and then these cancel, the x's cancel over here. So it'll just be equal to 1200. And now what we can do is on both of these sides, let me just extend this down. On both of these sides, we can divide. We're trying to get x by itself right here, so it's x times the sine of 23. So that means that if we want to get rid of the sine of 23, we have to divide by the sine of 23. And let's do the same thing to this side. Divide by the sine of 23. So it cancels over here, and we're left with an x. So we can say that, I'm just going to carry this right over here, x is equal to 1200 divided by the sine of 23. Okay, so we got that. Now let's figure out what the sine of 23 is, and that's what we got to pull out our calculator. When you use your iPhone calculator, it'll show up like this. If you turn your phone sideways, you should get something that looks more like this. We're using sine. So what I'm going to do is I'm going to do 23, then I'm going to hit the sine button, and that's 0.39. So let's go back to this. So really what we have here is x is equal to, what was that number again? 0.39, okay. X is equal to 1200 divided by 0.39. 0.39. So what is 1200 divided by 0.39? Divided by 0.39 equals 3076. Let's call it 3077. Let's round this up. 3077. And what unit are we in? We're in meters. So 3077 meters. That's about 3 kilometers. So that's the distance from P to the airplane. So we just found this distance here. We found the hypotenuse of the triangle, and you can say this is our answer. This is the distance from point P to the plane. Okay, so what I want you guys to do now is I did 4, you guys do 5, 6, and 7. But you can see the pictures. You see how the pictures are pretty similar here. And I guess for 6, you got to come up with your own picture. So I'm curious what you guys do for that.